Hello, you're welcome back. All right, still on temperature and thermometer. Here we are going to be looking at absolute temperature. Now, what's absolute temperature? Now, absolute temperature is actually the temperature that is measured in Kelvin. Okay, so Kelvin temperature, right? Temperature in Kelvin scale is known as absolute temperature. And the highest temperature in Kelvin scale different from temperature in degrees Celsius. All right, so we can always convert temperature in a Kelvin scale. Okay, I believe you know this already by adding 273, okay, to the temperature in degrees Celsius. So you can always convert temperature in degrees Celsius to Kelvin by adding 273 to that temperature in degrees Celsius. For example, okay, if the temperature in degrees Celsius is 27 degrees Celsius, to get the temperature in Kelvin, okay, or let me just use K. Let me just use K. All I just need to do is to add 273, okay, to 27, which gives me 300 degree Kelvin. All right, I hope that is well understood. There's another phenomenon too we need to talk about. It's called absolute zero. Absolute zero. All right, so when it has asked what is absolute zero, remember we have zero temperature. Okay, we have the lower fixed point of our temperature in the Celsius scale, which is 0 degrees Celsius, but it is not absolute zero. It is definitely not absolute zero. Okay, 0 degrees Celsius is not absolute zero. Absolute zero is equal to 0 degree Kelvin. Okay, because at 0 degrees Celsius, in fact, you have, if you convert 0 degrees Celsius to Kelvin, all right, you add 273 to 0 degrees Celsius, you discover that you're having 273 Kelvin. I know that 273 is never, okay, the lowest temperature. So the lowest temperature actually is gotten when you have 0 Kelvin, okay? So, and that's why you call it absolute zero. So since absolute temperature is a temperature in Kelvin, okay? So when you have 0 in Kelvin, it becomes absolute zero. And now why is absolute zero of importance? Okay, at absolute zero, we know very well that that is the lowest temperature you will have. At that point, that absolutely zero heat. Okay, so the heat energy at that point, the heat of the molecules that we are considering, or the molecules of the matter, is actually zero. So that is the point where, okay, matter possesses no energy. The molecules of, if it is molecules of gases, it possesses no energy because it is absolute zero. All right, so please take note of that. Okay, now still talking about temperature scale, I think it is ideal that we solve some question based on temperature scale conversion. Okay, it's very much ideal. I will have some question. I'll bring some question, okay, to the screen and maximize them, then we'll do justice to them. Okay, so I hope you're with me. Okay, all right, here I have the very first question. Okay, an example. It goes this way: the lower and upper fixed point marked on mercury in glass thermometer are 210 meter apart. Okay, so 200 lower and upper fixed point is 210 meter apart. So you have to draw that scale. You know, is for you to actually convert temperature, it's good for you to actually get your upper and lower fixed point. So in the mercury in glass thermometer, okay, the length between the upper and lower fixed point is 210 meter, but that means it is from 0 to 210 millimeter. 210 millimeter. So that's what they mean. I've just written that from 0 to 200 millimeter. Okay, let's continue with the question. Apart. All right, now the end of the mercury column in the tube is 49 millimeter above the lower fixed point. All right, so that means we are looking at the point above the lower fixed point, which of course is 49 millimeter. Okay, I'm very sure that we are being asked to find the equivalent in Celsius. Okay, so above lower fixed point in the room. Okay, what is the temperature of the room in degrees Celsius? Okay, so as I already told you, it's just as easy as that. So you're converting now. This what you're doing here is you're converting millimeter, all right, scale in millimeter, then to scale in degrees Celsius. So all you just need to do, take your upper and lower fixed point. For Celsius, of course, the upper fixed point is 100 degrees Celsius. Lower fixed point is 0 degrees Celsius. Okay, so we're looking for temperature that is equivalent to 49 millimeters. So I can call that theta degrees Celsius. Of course, you know how we do that. Okay, let's start with Celsius scale. The difference between the upper and the lower fixed point. I'm gonna have, okay, please pardon me. I'm going to have 100 minus 0, then divided by theta minus 0. The same thing is applicable to this. 210 minus 0, then divided by 49 minus 0. Okay, 210 minus 0 is 210. Theta minus 0 is, of course, is still theta. So I cross multiply. So I'm having 210 theta. Okay, in degrees Celsius. 49 minus 0 is 49. Multiplied by 100, I'm going to have 4900. 4900. So that's when I can get my theta. The temperature in degrees Celsius that is equivalent to 49 millimeter. That is going to be 4900. Then divided by 210. Okay, so let's work on that. Okay, you can actually get a calculator to do that. Just divide 4900 by 210. 23.3 degrees Celsius approximately. As simple as that. Alright, let's find another question. That should be another question. Alright, here I have another question. This one is based on resistance thermometer. Okay, it goes this way. Platonium resistance thermometer wire has resistance of 5 ohm at 0 degrees Celsius and 5.5 ohm at 100 degrees Celsius. So that is the upper and lower fixed point. So you gotta draw that. Draw that. 0 ohm at lower fixed point. The 5.5 ohm at upper fixed point. So what are we looking for? So we are looking for the temperature. Calculate the temperature of the wire when the resistance is 5.2 ohms. So we are looking for temperature in degrees Celsius that is equivalent to 5.2 ohms. All right, so draw my scale for the Celsius, which of course lower fixed point is 0 degrees Celsius, upper fixed point 100 degrees Celsius. Temperature equivalent to that, I can still call it theta degrees Celsius. Okay, so we take our length 100 minus 0 divided by theta minus 0 is equal to 5.5 minus 0 all over 5.2 minus 0. Okay, of course, you know what we'll do. 5.5 minus 0 is 0. Cross multiply, and that's going to give me 5.5 theta equal to 100 multiplied by 5.2. That should give me 5. Okay, that's 5,200. If I'm not mistaken. No, 520. That's 520. Please pardon me. So that means my theta now. Theta degrees Celsius is going to be equal to 520 divided by 5.5. So what do we have? So 520 divided by 5.5. That's 94.5 approximately. degrees Celsius. All right, I hope that is well understood. Did I make any mistake? Oh, I really made a mistake. Okay, my lower freeze point is not 0 of the resistance. The lower freeze point, okay, is 5. Upper freeze point is my lower freeze point is 5. Upper freeze point is 5.5. Okay, so that was the mistake. That's why I didn't get the same answer. So lower freeze point here is 5. Please pardon my mistake. All right, so invariably I gotta change that by changing that to 5. Also changing this to 5. Okay, let's go there. So with what we have now, you know very well that this is gonna be 5.5 minus 5, that's 0.5. Then 0.5 multiplied by theta. So here, what I'm supposed to be having here is just 0.5 theta. And of course, this 0.2 times 0.2 times 100. So what I should have at the right hand side is 200. Okay, 200. Okay, 200. So with what we have here, so I'm having 200 divided by 5.5. So 200 divided by 5.2 minus 5, that is 0.2. So that's going to be 200 divided by 0.2. Okay, 200 divided by 0.5, not 0.2. Please pardon me. So that should give me 400. Okay, so I should be correct now. I should be correct now. Okay, I'm not still correct. Where's the mistake now? 0.2 times 10 is 20. Okay, please just pardon me. I'm not really in that mode of calculation now. Okay, but just it's 20 divided by 0.5. Okay, here is 40 degrees Celsius. Okay, I'm very sure that from this formula you know what to do. Okay, so it just all I just did was to apply formula. Okay, so that is it. So what is left for you to learn still on this topic is to look at the construction of different thermometers, ranging from mercury in a glass thermometer, okay, resistance thermometer, thermocouple. We'll just study how this thermometer are being constructed, which you can do, go research on them, okay, and of course study the difference between these two thermometric liquid, alcohol and mercury. What's the advantage of alcohol over mercury? Okay, so, and of course vice versa. All right, we can still do that in the next video. All right, see you in the next video. Thank you very much.